The first part is that the disto needs to be leveled. So you typically have something like this. Once you place it on the tripod, or let's say on the ground or wherever it is, it needs to be leveled somehow. So you want to make sure that that bubble inside of it is leveled properly inside. And once that is the case, now you have the ability to know where your orthogonal axis is, or your axis basically with respect to that is going to be. Then you have the ability to now simplify how it is. Now your movement is basically going to be rotation-wise and rotation-wise in two directions. Then you basically point the particular laser there, and it emits back. It identifies what the distance is with respect to that, right? And then you typically have these targets. So these targets, you can find the center of it quite accurately as well, because now you can move the device in a particular way to know exactly where it is. But these targets are very much used in order to be able to register between the planned and the BIM. So typically in the BIM, you have particular layout of a particular grid. You have some control system, the control points with respect to the overall, let's say, construction. From this, you need to be able to say, okay, these points need to be these particular points. You need only 3 of them to be corresponding between your BIM and your reality. And in order to perform that, you can place these targets there with pre-surveyed, with good position and orientation, to be able to know where that particular position is of that center. Once you have 3 of those, then you would be able to perform the rigid body transformation. Once you have that, you also have a remote control to be able to basically move it around, and of course an app that I'm going to be talking about here as well. You can have it both on your iPhone or your laptop as well. So how it looks like is this. So this is basically the app. You move and you slide the mouse. Of course, sometimes it goes a bit further or backwards. And then you basically click either on a particular location, or you again slide the mouse in a particular place. And then you tell it, okay, go to a particular location and then go up. And then once you have that, then you can say, okay, where that particular target was. You can again just click on it. Click on this. Then once you clicked on it, then you can go and zoom in and find the position of the target center exactly. And once you found the position of the target center, more or less, then what you do is you basically either use the remote control and press that red button, or you basically use the dist function there. You basically use this here, and then you basically, once that's the case, then it creates the distance there for you, and it shows you where it is exactly. And once you have that, then you can go and find where the rest of the targets are. And as you can see, it basically shows the red here on where that particular target was. And then you go and you move it to the next target that you want to see. And then essentially what it does, it finds the orientation of your particular instrument with respect to the original initial orientation. So it can provide you with a relative position from that original points that existed there. So it can figure out essentially what the distance is, what the orientation and whatnots are with respect to your initial coordinates frame. So this is the second one. Go there. Basically, again, go a bit closer. Try to zoom in the middle there. And this is more or less good. Again, we would be able to perform that and see how it looks is exactly that. In reality, it provides you with a red dot. And that red dot is an indication of this is exactly where it's supposed to be. Now, for the targets, it's obvious that it's going to be there. For the rest of the items, let's say if you want to take a look at a particular grid somewhere else, or see how it is, different types of, let's say, targets and whatnot, then you have some other problems with respect to that. So you need to know where it is that it's actually been measured. Something to be able to keep in mind. Then again, go forward. As you can see, it's not sometimes as easy to be able to perform and find exactly where we need to go for the particular targets and position, particularly given the fact that if some of these are a bit closer to you, it's going to be quite challenging. However, then you can go and, of course, zoom and see how it is. And really, the initial part, especially the manual parts, might be a bit tedious. However, you can still get significant amount of points in a very, very accurate manner. I believe up to a millimeter or 2 millimeter accuracy in this way as well. Now, where it would be quite a bit beneficial is when it performs this completely automatically, where you can provide it with, let's say, some indications of boundaries of where it's supposed to be searching for, and then it starts searching for the overall, each and every one of the aspects with respect to that as well. Then this is another control point that we're going to be looking at. Once we have that control point as well, we have the ability to be able to perform that rigid body transformation that we talked about. Of course, we only need 3, but if we can have 4 or more, that would be better, because it's a least squares adjustment. And with least squares adjustment, because you're going to have some random measurement errors, you're going to have some problems with respect to that. So the more points that you have that are non-collinear, the better it is going to. Of course, this is the next one. Then that would be the last one. And now this can also be utilized for you to be able to, let's say, define exactly those reference points for instance, your augmented reality. Now, if you have those accurately and properly, this would be a good option for us to be able to perform that and take it from there. Okay. So the second part that I wanted to talk to you about is laying a simple floor plan. So for this here, I just use the particular toolkit, but you don't necessarily need to use this toolkit. You go and you essentially go and find multiple different types of points wherever you want to look at. So I say, okay, I want to lay out these points, particularly here. So from here to other places as well, just something very, very quick and easy on exactly the plane there. So you go and you click on the dist. It shows you where you are. Then you go and let's say you go and find a particular corner there on another place. You either click and it goes a particular area, or you basically move it. And with the movement, again, it's not as intuitive, so you have to be a bit careful when you're using the mouse there, how much you're basically dragging it. Sometimes I had to actually look back and take a look and see where my laser is actually pointing, and am I anywhere near where I want to be or not. So this is something also to keep in mindful as well. And then again, another corner, we would be able to get that. You basically press the distance, and this is a typical, process where you can follow, and then you can find more and further points of interest as well. You basically perform exactly that and take it from there. So again, you go to the target measuring section, and then from that, you basically go and click on where you're supposed to be going. And then measure the distance. Go again, you measure the distance. The reason why I wanted to show you as well is because you see you have some constraints with respect to where you can actually go, and that is more or less with respect to some interruptions that exist in the line of sight. Meaning a lot of these times you need to perform data and collect data in multiple different locations. Then, for instance, you can get a particular location there, which is again an approximation. And just as a demonstration, then you can go and find the distance there and so on and so forth. Go on the same line, basically click on that. So the good thing is that it, to a good extent, can understand and follow where it's supposed to go. And here it just thinks that the target is too low. So you have to basically maneuver it in a particular way that it allows you to move without it tilting significantly low in a way that it is out of its coverage area. Then here, the last one that I'm going to show you at this area is basically here where you're going to go to the very end and take it from there. That is basically the other corner of the lab there. And here, again, we go to the other corner. And essentially we go back. And when we go back, it would give you basically the floor plan here. Of course, this is not a perfect floor plan, but you get the idea of how it is that you can utilize basically your mouse or your smartphone or anything else to basically move it around and take it from there. Now, what is important is that you can also utilize this to find the relative position of a point with respect to another point. So you go and find, let's say, a particular target, and you say, okay, I want you to show me a point that is 1 meter, let's say to the right and 1 meter to above, and then it would basically take the ray of light that is supposed to and show you the exact same position there as well. And this is that example. So the first thing is for us to measure an initial point. Again, we go up. I want to show a particular position there, let's say targets or position that I'm looking at. Okay. Then it says how much right, how much left. You say, okay, 1 meter right. And then you say, okay, or 0.5, however way you want to do it, but it provides you with a relative position. And this function is going to be utilizable for when you're actually laying your grid in a particular way and where you can actually start clicking on it and understanding it. And then do we want 1 meter up, 1 meter down? Where do you want it? And once you have that, essentially, once it's measuring, it basically shows you where it is. And as you can see here, it's this red dot here. I don't know if you can hopefully see it, but that's where that position is going to be with respect to the other point. And this is beneficial. Why? Because we can now utilize this throughout in order for us to be able to find relative positions of particular points there. Now, how is this important for us in construction? Of course, if we have the ability to say where a particular point is, as I showed in the robotic total station example, we can use it for tolerance checks. We can use it to make sure a particular place, where a particular place is going to be, that we're, let's say, placing a particular column, or how it's being utilized right now is with respect to, let's say, if you're trying to use a robot to drill a particular location. How do you direct the robots in a construction project where to actually go? And typically with these laser systems, you can go hand in hand and basically show the robots that that is that red area, and the robots with the vision system can actually go exactly there and start drilling that location. So the last part that I want to talk to you about with the robotic total station and the Disto is with respect to laying a particular grid area. So here I said, okay, I want a vertical grid, and I want to use one of those panels there for one of the doors of my lab. And basically you have to select the boundaries of where it's supposed to be, and then really you need only 2 points so that it can understand where it's going to start and from which 2 points it's going to start. But you can provide it with more than that and say, okay, I actually want it from this particular line, not from the other line. So you have the option to basically select multiple different lines if you actually do choose to do so. And from this, you basically go, identify the distance there. Go to the next one. Take the distance. And then here you have the ability to say, okay, this is good enough for me. Now it says, do you want to import a particular arrangement of grids, or do you have a particular grid arrangement? Or do you want a new one? And you say, okay, yeah, I want a new one, and I want this rows to be 20 centimeters, the columns to be 20 centimeters. With respect to what line, it actually identifies that line that you want. You can also identify another line, it doesn't matter. And then it says, okay, you can go up and down to say where you want it to start. So I wanted to start a bit further down there, let's say. So I'm going to start such that the second point actually coincides with that particular grid point. That is here. And then the cool part about this is that now I can say, okay, and of course I can introduce the grid with respect to other lines as well. Now, the cool part about this is that you just basically go and select a particular point and it starts measuring. So you select this point, and then you say, basically you click on the dist. And what it does is it basically starts showing it in reality. And this is basically how it's going to look. And that is that particular point. Similarly, you go and you do another point there. Say distance there. And what it does is, again, it goes and it finds that and starts showing it exactly where it is. And this is beneficial so for surveying and for every other application. Specifically, if you import these grids, now you can utilize it and one by one basically show it. And then you can basically have either a robot or a person directed exactly at the proper location to be able to place a particular item in that particular grid as it's been requested and required. Then the last one is here as well. I'm going to show you. that again. Once it's showing, it basically shows in this type of blinking manner so that it could provide you with the proper means of measuring each and every one of those points that are required with respect to a particular initial point. Okay. So now that we know the benefits